Okay, so we're going to be finding the dy dx by implicit differentiation for e to the power of x cosine y equals x plus y. So we can see here that we're going to be using the product rule, so we have to find our f of x, g of x, f prime of x, and g prime of x. We know that our f of x is going to equal e to the power of x. We know that our g of x is going to equal cosine y. Now our f prime of x is also going to equal e to the power of x, because when we find the derivative of e to the power of x, it just stays the same. And g prime of x is going to be equaling negative sine y times dy dx. Now we multiply it by dy dx because dy dx is the derivative of y with respect to x, and we have a y involved in this part here, so we just have to have that there, since it is the derivative of something containing a y. And so we can go ahead and start using the product rule now that we have all the parts that are included. So we have our e to the power of x times negative sine y dy dx plus e to the power of x times cosine y. And also we have to have the derivatives of x and y at the other side of this. So we know that since they're just independent variables, that it'll just be 1 for each of them. So we have 1 plus 1 times dy dx. Since that y is a y, the derivative of something with a y will be the derivative of y with respect to x. So we just have to multiply that by dy dx. And so we can go ahead and combine these, and we have negative e to the power of x sine y times dy dx plus e to the power of x cosine y, which will equal 1 plus 1 dy dx. Now what we want to do is we want to isolate that dy dx to only one side of this equation here. So we can go ahead and subtract 1 dy dx from the right side and add it to the left, and we can subtract e to the power of x. No, I mean negative, e to the power of x cosine y, and subtract it from to the right. So we'll have negative e to the power of x sine y dy dx minus 1 dy dx equals 1 minus e to the power of x cosine y. So that way we have dy dx only on the left side, makes it a whole lot easier. And since we see that they both have dy dx on the left, we just multiply these parts by dy dx. So we have dy dx times negative e to the power of x sine y minus 1 equals 1 minus e to the power of x cosine y. And so next we want to divide both sides by negative e to the power of x sine y minus 1, which will give us dy over dx equals 1 minus e to the power of x cosine y divided by negative e to the power of x sine y minus 1. That's how we find the dy dx by implicit differentiation.